Many times, chapters of Psalms have a double meaning where events described from the psalmist's experience are also describing events of the past or future. Psalms 18 it was written by David about his deliverance from Saul. But David's description of torrents, storms, dark rain, clouds, hail, thunder, lightning, and being drawn from the deep water bear a striking resemblance to experiences that Noah would have had. If this chapter has a double meaning related to the flood, then Psalm 18:15 seems to be describing something very similar to the hydroplate theory's rendition of how the mantle foundation of the earth was exposed and laid bare as the granite plates slid away from the rising mid-oceanic ridge. As will soon be explained in detail, the mid-oceanic ridge appears to have first buckled up in what is now the Atlantic Ocean. This uplift in the Atlantic caused the plates to slide downhill. This was only possible because the plates were well lubricated from below by remaining trapped water of the deep, thus the theory's name Hydroplate. As these continental plates rapidly slid away, the compressed Atlantic floor continued to spring up roughly 60 miles until it again reached hydrostatic equilibrium. As this continued, the plates picked up speed, and because of their great mass, they gained tremendous kinetic energy. This rapid continental drift was not only due to the rising Atlantic mantle, it was aided by another process occurring deep within the earth at the same time. As the mantle buckled and rose up, it did not open up a void because pressures at such depths are too great for any void to actually open. This condition means that the material could only move by shearing, which produced friction and heat like when you rub your hands together back and forth. As shearing continued at greater depths and pressures, the tremendous heat generated melted the shearing walls even if they only moved a few millimeters. As the chamber floor rose to become the Atlantic floor, mantle rock below that floor had to rise as well, thus the Pacific side of the Earth sank. Once melting occurred along one of these deep vertical faults, a point of no return was crossed because, as we've already discussed, magma generated at these pressures below the crossover depth is so compressible that its density increases, causing it to sink. The more it sank, the greater its pressure and density becomes. Eventually, the magma ends up in the Earth's core, where its density is about twice that of the compressed solid rock inches above the core. Therefore, for every 2 units of mantle volume that drained into the core, only 1 unit of volume was added to the core. While the Atlantic edge of the plates were pushed up by the mantle as it moved toward hydrostatic equilibrium, rock on the opposite, or Pacific side of the Earth, was rapidly pulled down as the deep mantle melted and contracted by 50%. This tipped the plates to an even steeper incline and produced tremendous suction. Within hours, shearing occurred around what is now the Pacific Ocean, specifically along a horseshoe-shaped path called the Ring of Fire. This explains why the Ring of Fire is the most volcanically and seismically active region on Earth. For the floating continental plates, these two forces, both powered by gravity, simultaneously caused a rapid drift away from the bulging Atlantic floor. Because the plates were lubricated by water, they easily slid and rapidly gained speed and momentum. Later we'll cover, in much more detail, exactly how the center of the Earth melted, which resulted in subsidence and burial of the Pacific plate. But for now, we will continue to follow the chain of events occurring on the rapidly sliding American, Eurasian, and African plates. This rapid sliding of plates resulted in the formation of the Atlantic Ocean Basin and explains why the Atlantic shorelines of the Americas and the Euro-African continents fit so snugly against the base of the mid-Atlantic ridge. Eventually, the rapidly sliding plates either ran out of lubricating water and ground into the mantle or hit obstacles like the mid-oceanic ridge in the Pacific. Hydroplate theory labels this the compression event, which occurred in approximately 1 day as the plates crashed to a halt. Friction from the fast-moving plates sliding on rock at high pressures melted the surfaces. Because granite is composed of differing minerals with differing melt points, most of the magma produced was from quartz, which has the lowest melting point of granite's 4 base minerals. Water still trapped under the plates and in the sliding porous surfaces dissolved into the accumulating magma, which dropped the magma's melting point even further. As the plates decelerated, the tremendous momentum fractured and thickened the material as it compressed. As the material buckled, fractured, and thickened, the forming continental surface rose high up out of the floodwaters. Rising mountain chains and thickening plates lifted and trapped large inland seas on top of the continents. Much of this water remained trapped for centuries. So after the flood, much of the continent's shelves were above sea level. For several generations, animals and people were relatively free to move from continent to continent. As the plate material was rapidly crushed, most cracks were quickly filled with extremely high-pressure quartz magma injected into them from below. Coal and oil deposits are viewed as the product of millions of years by evolution. However, multiple lab experiments show that these materials can be rapidly produced via extreme heat and pressure. Likewise, metamorphic rocks like marble and diamond form quickly under similar extremes. Carbon-14's rapid decay rate should yield extremely low, almost non-existent levels in these deposits if they're millions of years old. However, the consistent measurement of large concentrations of carbon-14 in coal, oil, and even diamonds is a glaring contradiction to the millions of years concept. This is rarely discussed. Hydroplate theory's concept of a recent compression event as a result of the Genesis flood provides the work required to generate the extreme one-time conditions that produced and concentrated these organic-based products rapidly. Of course, the high carbon-14 levels are expected if this all happened very recently, rather than a surprising anomaly for theories that promote an old Earth. This is all well and good to show in an animation, but what physical evidence is there for rapid deceleration and crushing of the continental plates? Areas like deep canyons with deep fractures reveal the top of the bedrock granite of continents. Here we see Colorado's Gunnison Canyon. These areas indeed show that the material has been rapidly crushed and injected, producing a spider web of quartz veins. Only rapid crushing combined with the lowered melting temperature of water dissolved in quartz would explain why both large and small cracks are filled with quartz. The dissolved water in the quartz kept the magma in a liquid state for longer, allowing it to fill both large and even small cracks before it solidified against the colder rock walls. The quartz-filled cracks of the Grand Canyon's deep inner gorge also reveals this evidence of rapid crushing. While the basement rocks show that the material was rapidly crushed, many sediment layers further show that this crushing and compression must have been due to a rapid and massive deceleration event. How were these sandstone layers tipped and beveled so evenly? This again points to a rapid, one-time event. Similar evidence is seen on a large scale. The Grand Canyon's great unconformity of beveled layers speaks to the scale of this event. Layers below appear to have been cleanly sheared off with flat layers then stacked above. What forces or mechanisms could do this so evenly? Uniformitarian geology's label of unconformity betrays the lack of an explanation for this feature. We'll soon see beveled layers are actually strong evidence in support of hydroplate theory's compression event. Uniformitarian geologists note that fossils are only found in the horizontal layers above the beveled line. This has led to the belief that life suddenly began after these layers were beveled. This is termed the Cambrian explosion, where all animal and plant life suddenly appear at the base of the Cambrian layers. Rather than speculation, hydroplate theory will show the mechanism that explains why fossils are only found above the Great Unconformity. The crushing, compression, and deceleration of the compression event readily explains all these observations. If you'd have placed an indicator in the soft sediment layers produced by the flood before the compression event, it would have moved with the rapidly sliding plates and sediments. But as the plates crashed and began slowing, the indicator would have bent in a direction of the deceleration, showing that the force of deceleration was present and indicating its direction. As the deceleration occurred, resistances not only slowed the plate but compressed it, causing it to buckle up at certain points of weakness. This caused the soft, unhardened layers still filled with water to incline and deform with the buckling plate surface. As the plates decelerated and compressed, the sediment layers did too. Because they were still all water-filled and unhardened, the compression and repacking of particles once again produced massive liquefaction within the layers, as water was squeezed out and forced up. Because the layers were all now steeply angled rather than flat, any low-density items like flora and fauna were rapidly swept into and along reopened water lenses within the layers. This material was transported uphill as water powerfully flowed from high to low pressures. This explains why lower regions below the Unconformity contain no fossilized remains. As layers were lifted up above the apex of buckled regions during the continued and increased deceleration, uncemented particles above were no longer supported by the solid crystalline rock below, and a shear plane quickly developed between supported and unsupported grains. These upper sediments were quickly infused with the waters flowing up from the liquefaction lenses of the tipped yet supported layers below. The flora and fauna from these lower layers were rapidly transported into the upper sediments. Eventually, the unsupported sediments, plants and animals, now infused with lubricating water, slid along the shear plane, which easily beveled the still soft layers below. As this occurred, liquefaction again sorted particles, forming new horizontal layers above. Notice how hydroplate theory is the only theory that provides detailed cause-to-effect reasoning and a physics-based description of forces and mechanisms explaining how these features formed. Conversely, those whose theories do not expect or can explain this continue to call this a great unconformity. At this point, you've already seen how entire mountain chains formed on the continents. Rather than millions of years, this occurred in hours. But let's discuss this further. Just as a thin sheet slid on a smooth surface buckles and deforms along the leading edge where it encounters resistance, so too the leading edges of the continents buckled and thickened the most along the leading plate edges, which were the first to encounter resistance. This explains why the dominant Andes and Rockies mountains formed on the leading western side of the plates and run parallel to the Atlantic Mid-Oceanic ridge. Likewise, the dominant mountain chains of Africa also run parallel to the Atlantic Mid-Oceanic ridge, but as expected are located on the eastern shore of the continent. Here is yet another example of evidence of rapid compression that must have occurred while all layers were still soft. Rock does not bend. This picture of finely compressed layers in the mountains of British Columbia is impossible to explain from an evolutionary perspective of individually deposited and hardened layers over millions of years. Material mechanics does not support this idea. Hard and brittle rock layers do not deform like this without cracking in hundreds of locations. All these layers must have been soft, having been deposited at the same time. Months later, while still unhardened, they were rapidly compressed like an accordion as the sliding North American plate decelerated to its current position. Later, limestone precipitated out of the water and the water drained out, cementing the deformed layers into hardened, brittle rock long after the deformation. This yet again supports the idea that the high mountains we know today formed quickly after the flood. Large plateaus are found adjacent to large mountain chains. The Colombian, Colorado, and Himalayan plateaus all lie next to thick, massive mountain ranges. Geologists like Professor George Kennedy recognize the puzzle presented when attempting to explain observation by physical means. He asks, what mechanism would cause a large volume of low-standing continents to rise rapidly a mile into the air? Furthermore, evidence from gravity surveys suggests that the rocks underlying the Colorado Plateau are in isostatic balance. That is, this large area is floating at its correct elevation in view of its mass and density. Recent seismic evidence confirms this in that the depth of the moho under the Colorado Plateau is approximately 10 kilometers greater than over most of continental North America. Kennedy concludes, we have then a double-ended mystery, for the Colorado Plateau seems to have grown downward at the same time that its emerged part has arisen upward. Here we see graphically what Kennedy found so peculiar. What forces caused the plateau's layers to rise up, while at the same time the density boundary of the Mohorovičić discontinuity was forced down? With a lens of millions of years, the forces involved are vague and mysterious. Terms like uplift may vaguely explain what obviously happened, but it completely fails to provide a mechanism that actually explains the results that we see. Hydroplate theory readily explains the forces and the mechanisms that lifted the plateaus. Let's explain. It was simply hydraulic lifting at work due to temporary imbalance of forces after the compression event. The causal force was again gravity. As newly formed massive and high mountains sank down, the relatively thin adjacent continental material was hydraulically lifted over time, creating a plateau. Large plateaus are always found adjacent to large mountain chains. The Colombian, Colorado, and Himalayan plateaus all lie next to thick, massive mountain ranges. Hydroplate theory uniquely explains the essential conditions that both raise the plateaus and cause the moho beneath to be depressed. But where did the liquid under these mountains come from? As we've seen, magma chambers are not the result of plumes rising against all odds from Earth's core. Rather, the magma was produced by the friction and heat generated as the buckled and thickened mountains sank into the mantle. Water then dissolved in the magma, reduced its melting point, and this is why volcanoes in these areas today release so much water during eruptions. These volumes of magma were generated mostly under buckling mountains, which in turn contacted more heavily with the mantle surface as they slid. Over the centuries following this event, the magma under the mountains was slowly injected under adjacent thinner layers of the plates. Again, notice the lack of mystery here. This all happened as a natural function of gravity acting on massive mountains as they slowly sank like giant pistons. The fluid beneath spread sideways under the thinner adjacent crust until enough pressure was generated to shear the material above. This shear line formed a somewhat vertical fault. The fault was injected with magma from below, which lubricated each new block and allowed it to rise even further until it locked up against the neighboring block. Once the block was either restrained or rose high enough, continued pressure from the sinking mountains began building pressure under the next segment of material. Once it failed in shear, it too was lifted, and this is how block faulted features like the Grand Staircase formed. It is also the mechanism that lifted plateaus to their current state. Since each block's mass and area was tiny compared to the mass and area of the nearby sinking mountains, the blocks were raised over a mile above their surroundings. Along some faults, pressurized magma reached the surface and spilled out on top of sedimentary layers. The hot liquid pooled at low points in the topography and hardened and years later protected the sediments below from violent flows as huge inland lakes breached and scoured away soft sediments as they drained. In some areas, these became buttes like Red Butte in northern Arizona, which is capped with a thick layer of volcanic rock. The weight of the injected magma combined with the weight of the lifted plateau and the simple driving mechanism of gravity further explains the second half of the Plateau Mystery. Naturally, the moho boundary was pressed down by the extra weight of the magma under the plateau as it too settled back into hydrostatic equilibrium. Two more observations are also explained. Mountains were heaviest, so they settled more. The moho is the deepest under the mountains. Conversely, the moho is exceptionally shallow over ocean basins. As the continents settled down, the ocean floors had to rise in compensation for the downward flow of matter, just as the topography of a waterbed does when you lay on it. Finally, the hydraulic lifting of the plateaus is the key to understanding how the Grand Canyon actually formed on the Colorado Plateau. As the plateau was lifted, huge inland lakes were lifted as well. Here is a map of the Four Corners area of southwestern United States. Some people will say the Grand Canyon was carved during Noah's flood. That is not really correct. It should be seen that the flood began a series of events which after several centuries resulted in conditions which carved this unique canyon. Centuries after the flood, as the Rocky Mountains sank, the Colorado Plateau was hydraulically lifted. Two huge inland lakes, Grand Lake, discovered by Walt Brown, and Hopi Lake, were located on this forming plateau, and they were also lifted. Eventually, Grand Lake, with a volume of about that of Lake Michigan, breached a natural dam located at the funnel feature in this circle. It spilled out across the upper sediments, still soft and impregnated with floodwaters. Once the body of water began flowing, the low pressure caused all waters in the lake to flow toward that low pressure point. As happens with flowing fluids, a widening funnel-shaped channel was quickly carved and the lake spilled out over the sediments in northern Arizona. The eroded funnel scoured sediments until it reached the thick layer of hardened limestone today known as the Kaibab deposit. The erosion widened the channel to about 12 miles across and formed the Echo and Vermilion Cliffs, which overlook Marble Canyon. Because the material above was removed so quickly from the Kaibab, it buckled, arched up, and cracked in tension down the middle of the channel, producing narrow Marble Canyon, similar to what happened when the Mid-Oceanic ridge buckled up. Sediments were quickly washed away in sheet flow as water from the lake combined with water already in the sediments. These were the conditions which began what is referred to as the Great Denudation, where around 1,000 vertical feet of Mesozoic sediments were stripped off this region in northern Arizona. Remember how I said Red Butte near Williams, Arizona survived this scouring? Here is the most likely way all that volcanic rock ended up on top of it. At some points, magma from below the plates that pushed up the plateau traveled up along the sheared faults and burst out above the newly formed sediments. This naturally flowed to low spots in the sediment topography where it cooled and hardened. As Grand Lake breached, the torrent of waters eroded the soft sediments. As sediments were swept away, the thick, hardened layer of volcanic rock capped and protected the sediments underneath, forming a volcanic capped butte. As this massive sheet flow of sediments progressed, the flow eroded and undercut the western bank of Hopi Lake, which rested about 250 feet above Grand Lake in elevation. Hopi Lake soon breached and added to the catastrophic flow. There are many other strong evidences that corroborate this unique scenario that hydroplate theory presents. Like comets and asteroids, however, I will move on as this would greatly distract this overview. It should now be clear that the tiny Colorado River, which is a pretty normal river, even when it is not dammed up, could never have carved the Grand Canyon. Only the unique conditions explained by hydroplate theory fully account for how this land feature formed. To continue with the hydroplate theory overview, please click the following link to the next segment.